Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into Sir Michael Atiyah's insightful 2002 lecture, Mathematics in the 20th Century. Get ready for a whirlwind tour through a century of mathematical breakthroughs.
I'm eager to hear this. Atiyah's a legend, right? What are some of the major themes he highlights?
Absolutely. He identifies several key trends. One is the shift from local to global perspectives. Think complex analysis. Initially, functions were defined by explicit formulas, but later, their global properties, singularities, domains, became central. A similar evolution occurred in differential equations and number theory.
Interesting. So a move from precise, localized descriptions to a more holistic, qualitative understanding?
Precisely. And another major theme is the increase in dimensions. We went from single complex variables to multiple variables, from curves and surfaces to n-dimensional manifolds. Even linear algebra saw a dramatic shift to infinite dimensions with Hilbert spaces.
Wow, that's a huge leap. What about other shifts he mentions?
He also discusses the transition from commutative to non-commutative algebra, a huge development driven by Hamilton's quaternions, Grassmann's exterior algebras, and the rise of matrix theory. This had a massive impact, especially in quantum physics, with the Heisenberg commutation relations.
Right, the non-commutativity of quantum mechanics. I see. Any other significant shifts?
Yes, the move from linear to nonlinear mathematics. Classical mathematics often relied on linear approximations or perturbation methods. The 20th century saw a deeper exploration of truly nonlinear phenomena, like solitons and chaos, in differential equations in physics, Yang-Mills equations.
Fascinating. It sounds like a constant push towards greater complexity and abstraction.
Exactly. And Atiyah also explores the ongoing tension between geometry and algebra. He sees geometry as linked to spatial intuition, while algebra is tied to sequential operations, to time. He even uses the Faustian bargain analogy. The power of algebra comes at the cost of losing some geometrical intuition.
That's a powerful metaphor. I wonder if he overstates the dichotomy, though. Many mathematicians use geometrical intuition even when working algebraically.
You're right, it's a simplification. He acknowledges that. But the point is the fundamental difference in approach and the potential trade-offs. He then discusses unifying techniques like homology theory and K-theory, which bridge geometry and algebra, extracting linear information from nonlinear systems. These have found applications across various fields.
Got it. So these are tools for managing complexity?
Exactly. And then there's the pervasive influence of Lie groups, initially used to unify geometries, but later becoming crucial in differential geometry, relativity, and even particle physics. The classification of finite simple groups is another major achievement, although Atiyah playfully admits he wasn't initially thrilled with it, except for the discovery of the monster group.
Haha, the monster. That's a great anecdote. And what about the impact of physics?
A huge impact. Atiyah highlights how physics has increasingly influenced mathematics, especially in the latter half of the 20th century. Quantum mechanics, quantum field theory, and string theory have all provided new insights and problems for mathematicians to tackle, leading to breakthroughs in areas like Donaldson theory and knot invariance.
I see. So a kind of cross-pollination between disciplines?
Absolutely. He even suggests that the 21st century might be the era of quantum mathematics, focusing on the rigorous study of infinite dimensional spaces and structures arising from quantum physics. Other areas he mentions are non-commutative differential geometry and arithmetic geometry, both aiming for unification.
Amazing. It's a truly inspiring vision of the future of mathematics. Thanks for this summary.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Join us tomorrow for another exciting exploration of the world of technology and science. Goodbye.
Bye-bye.